Hello, ladies and gentlemen. Time for an example from proofs practice number 1. The point of this assignment is just give you some more practice with these proofs. We are just doing the same ones we've been doing. So we've done these sorts of proofs before, either in the notes or in the assignments that you've done in this unit. And we're just trying to get you more familiarized with them and be able to, remember them when it comes time for the test. And so we're actually not going to do this first few here. We're going to just do number 6, because this is an example of a level 3 kind of proof where you can prove something about a parallelogram or some other quadrilateral. Most of these are parallelograms. Let's look at this one here. We're going to prove that in a parallelogram, opposite sides are congruent, and we have our given, and we have the two things we need to prove here. So let's start our little T-chart here. We got some statements, if I could write correctly. Statements. And we'll get some reasons going on here. That was weird. Reasons. Make it up right. All right, reasons. Spend half the video just drawing 2 lines and writing out statements and reasons. So we got our given. So let's put those first. MJ parallel to LK. And JK parallel to ML. That was given to us. Make our V look like a V. So we got our first line here. We need to prove that, the opposite sides are congruent. So that's this congruent to this, this congruent to this. So that's what we need to end up with. Before we dive into the proof, what I highly recommend doing is figure out what your plan's going to be. Things would just go a whole lot smoother if you know where you're going and not just saying things because you're like, oh, I found a thing that's true, but instead figure out where you're trying to get to. So if we're going to prove that these opposite sides are congruent to each other, you're probably, and this is true for most of the parallelograms, you're going to have to cut your thing into 2 triangles. And the reason you want to do that is because then you can make a proof about those 2 triangles. So I can prove this triangle is congruent to this one. And once you have that, those 2 triangles are congruent, then you can say all sorts of parts are congruent, which would be like this side is congruent to this side because they're corresponding parts, and these 2 sides are also congruent because they're corresponding parts. And so, if you can split it into things that you can prove easier, then go ahead and do that. And so, in fact, that's what we're going to do. We're going to construct this line from J to L, and we're going to prove that this triangle and this triangle are congruent. And in order to do that, you're going to need some congruent parts. Well, we're going to have a congruent side here in the middle. That's going to be a reflexive property. And we don't have any other sides we can work with. In fact, we're trying to prove these are congruent. So we're not going to be using those until the very end. But we do have some angles that we can use. We can use these ones. Angles right there are congruent. And we can also use that these 2 angles are congruent. And that's because we got parallel lines and they're being cut by a transversal. And so we're going to get alternate interior angles. And so we're going to get those pairs of angles matching because they're alternate interior angles. And so we're actually going to complete angle side angle on our both triangles here. And so, we have a plan now. We're going to prove they're congruent by angle side angle. The angles are congruent by angles by alternate interior angles. And the side in the middle is congruent by reflexive property. And once we have those triangles proved congruent, then we can say opposite sides are congruent to each other because their corresponding parts are congruent. Triangles are congruent. So now we have a plan. Now we need to just write out what the plan is. So let's start with the first thing we did, which was construct. What's that? JL. That's just a construction that you can connect any 2 points you want. That's a normal thing we do with constructions. And we're going to say that JL is congruent to itself. That was the first thing we mentioned in our outline there. And that's by the reflexive property. And now we have this is congruent to itself. We're going to use these angles, and I'm going to number them just to make it easier to refer to them. So 2 and 3 are going to be congruent, and 1 and 4 are going to be congruent. And they're actually congruent for the same reason. So angle 2 is congruent to angle 3, and angle 1 is congruent to angle 4. We already established that we have parallel lines, and so when you cut it with the transversal, you're going to make alternate interior angles. And in a previous proof, you prove that alternate interior angles are congruent, which are actually right here, proof number 3. It's a thing we've done before. It's an angle proof, so we can use it for this one. So I'm going to say there are alternate interior angles. And so now we got 3 pairs of congruent things. We can say those triangles are congruent. Let me get the names right here. MJL, triangle MJL, is congruent to, and to get the other one in the right order, KLJ. And those are congruent by angle, side, angle. Now we have some congruent triangles. This triangle is congruent to this one. And now we can do the final part where we say that these segments are congruent because they are corresponding parts of congruent triangles. So we got MJ congruent to LK, and JK is congruent to ML. And that's by corresponding parts of congruent triangles are congruent. There we go. Proof done. Written out. Yeah, so that's an example of a level 3 proof. You just need to be able to navigate your way through and complete your proofs. So practice all with all the other ones. You got some triangle ones. You got some angle ones at the beginning. And then you got a few more parallelogram ones there at the end. So there you go. Good luck on all the other ones.